I like this equation just because it kind of makes us think sometimes, with the equals zero business. And it's a good problem. Like if you change this in a slope-intercept form, you would see right away why that zero it can just cause things to be a little funky, all right? So on this one, we'll go with the table option on this one again, even though you could change it in the slope-intercept form. So we'll say, again, we'll choose an x value that's 0 on this one, and this one you'll see it won't matter if you choose x or y is 0. But since x is 0, it's going to 0 out the 12x, which leaves us with 9y equals 0. And yeah, to solve this one, you divide both sides by 9 to get y equals 0. So going back to my original point there, was if you had chosen y to be 0 right here, you would have found x to be 0. So it just should be the same point. It's the origin right there. So what does this mean? Well, it means that we got to choose another point here. And, if I choose an x value that's a whole number, I can end up with some fractional values, which I assume you guys don't want because I don't want them. And graphing those on the computer can be a little challenging. So here's what I would notice. Okay, I see 12 and 9. I'm looking specifically at the coefficients of x and y, and I know the 0 is not affecting anything, so I can focus on these two numbers. Both of these are divisible by 3, right? Or they're multiples of 3. So I'm actually going to choose multiples of 3 as either x or y, and you'll see it's not going to matter which one we choose, or is it? Let me think about that a little bit harder. Yeah, it is going to make a difference. I can't choose a multiple of, I can't use 3 as y because that's going to give us another fraction. So I'm going to make this x value 3 on this, okay? Now, because I'm doing some analysis before we choose, you may have to actually do some trial and error on this before you find a point that's graphable on the computers, okay? But as for me, I'm going to say x is 3, and why did I choose x is 3? Because 12 times 3 also is a multiple of, well, 9 in this case, which we'll see here. So I got 12 times 3. I need a little bit of space on this. 12 times 3 plus 9y equals 0. So 12 times 3 is 36 plus 9y equals 0. Now subtract 36 from both sides. And 9y equals negative 36. Divide both sides by 9, and you get y equals negative 4. So we get the point 3, negative 4, which again, I'm actually not going to find that third point using the equation because, like we've shown before, you can kind of create a little stair step right here, which means it's just going to duplicate over here as well. So we would get this third point to confirm the pattern, but you'll get it no matter which method you use on this. So whether you said, you know what, I'm going to choose also the value that's negative 3 right here, you'd get a positive 4 there instead. Okay? And yeah, I'm just kind of looking to save time on this one, which is why I'm not showing that. But I definitely recommend using a third point to confirm your pattern and also to kind of check your math on this stuff, even though the graphs on the homework only require 2 of these points.